This is Greg Pasternak from Riverside Life. Recently, I've finally been producing a lot of videos I recorded from 2018 to 2023, touring a variety of streams around the state of California that were our classification sites and just trying to give you some insights into the variety of streams that we have. Before that, I had some videos that were far more diverse, covering a variety of topics from my perspective. And now I need to change things up again because we've been doing a really exciting project studying stream side encampments in the Bay Area, which has also required us to make a classification for the San Francisco Bay Area in California, but along with a lot of other things that we've been going on. And so I really want to share some of the developments from that project with you on this channel. Now, unfortunately, in doing that, I kind of have to revert back to a little bit of professor mode and giving some PowerPoints on and off. But I'm going to try to keep it more conversational than I would in just like a professional lecture. So we'll see how that goes. We'll see how you like it. Also, I think it provides some context because a lot of these classification site visits, I'm trying to explain ideas, but I'm not giving you like sort of a little bit more hardcore science about like what is this all about? What is classification? So I'm going to try to resolve that in this video right here, right now, with an introduction to some ideas associated with stream classification. And then we'll move back into some site visits, looking at sites around the San Francisco Bay Area as the next batch of sites. So I'm going to go ahead and switch to a PowerPoint. I hope you can bear with me. I'll try to not go for too long with this whole thing. So what I want to do is I want to set up this next round of videos in which I'm going to be introducing to you our 9-county San Francisco Bay Area stream classification. I'll tell you what makes this different from the other classifications that we have for the state of California and some things that really stand out. And I also want to point out that this work is not something that I've done by myself at all. A lot of the classification analysis has been done by my colleague, Dr. Jihao Wang, and we've been part of a consortium that I'm actually the leader of that includes 3 resource conservation districts from the Bay Area. It includes San Jose State University, of course, UC Davis, and University of California Agricultural and Natural Resources, and a really cool nonprofit called Safe R Cubed. That focuses on sort of geotechnical resilience, reliability, and hazards. So classification, right? I've been posting all these videos. Oh, like we're in this type, we're in that type, regional classification, state classification. Some of you may be rolling your eyes, probably already quit the channel. Some of you are like, hey, that's pretty cool. So why do we even bother with this? Well, look, it's just human nature. Humans, what makes us sort of special is that we're excellent at organizing things based on what they have in common and what makes groups of them different from each other. And of course, we classified all life on Earth, right? We have these massive classification system with all the hierarchical trees, vertebrates and vertebrates and all these sorts of things. You know, what is a frog? Is a frog an amphibian or an insect or whatever? And, does any of that really matter? How do we use all that? But it's important to understand that in classification, you first have to know what something is, as far as like, how, what are the features that make it a thing like an animal, okay, versus something that's not an animal. And then what makes different kinds of animals different. So that's what a classification helps you sort out. Now, one of the things I want to lay out here is the difference between genetics versus genetic, and you'll see why shortly. So the noun genetics was first coined by William Bateson in 1905, and it describes the study of heredity and the variation of inherited characteristics because of what people were learning about, how humans are different from other animals. If somebody had plants and you're making peanuts or you're trying to make a better apple, like that led to a lot of thinking about what we now call genetics. And of course, DNA and its structure weren't determined until much later. But even though the term genetics is newer from 1905, the term genetic has existed for a long time before that. In fact, it derives from the Greek genetikos, meaning origin or genesis. And in particular, there's a geographer, William Morris Davis, and he used the term genetic to mean the origin or formation of things, as in the genetic classification of landforms. So I'll be coming back to this in a moment, but I want to set this up now because it's really important to understand that when we're talking about the Earth or organisms on the Earth, part of classification is understanding where things come from. And that means understanding the genetic, of it, not genetics in terms of like DNA per se. So when we look at classification, we can just simply look at the most basic idea going back for thousands of years, what the common people will understand, which is this philosophy that is well stated in Confucius, but it says, if names are not correct, language will not be in accordance with the truth of things. If language is not in accordance with the truth of things, affairs cannot be carried on to success. When affairs cannot be carried on to success, rights and music do not flourish. When rights and music do not flourish, punishments will not be just. When punishments are not just, the people will not know how to move hand or foot. Therefore, a gentleman must be careful about what he names and how he speaks. This is no small matter. I just think, that's kind of a lot of a paragraph, but it's just we have to know things by their right name. What are they and what is in a name in the first place? And so, as I mentioned, there was a geographer uh, leading into the turn of the 20th century, William Morris Davis, who is incredibly influential in our understanding of how the Earth's surface functions, geologically. But he was a geographer, and he has, for example, this quote. From the very beginning of geography in the lower schools, the pupils should be possessed with the belief that geographical forms have meaning, and that the meaning or origin of so many forms is already so well assured that there is every reason to think that the meaning of all the others will be discovered in due time. I mean, I see that this is just a variation of what Confucius was saying, that, there's more than just a name. I mean, okay, my name is Greg. Well, I don't know, maybe that doesn't mean anything, but, it's within the name is the information that we sort of imbue into it. If I say arm, it's not the word arm may not inherently mean anything, but a lot about what I'm talking about if I say the word arm. And that's why it's important to have classification. So when we look at rivers in particular, we can define a river based on something that all of these things have in common. And what are some of those things? Well, first of all, at some time or another, they carry water. I mean, yeah, you can have rivers in the desert, and most of the time they'll be dry. Maybe even 99.9% of the time they'll be dry. But the landform itself is something that was formed by and carries water at some point of time. That is a river. We can also say that all rivers have in common that gravity drives water to flow from high to low elevation. Now, that's not always the case when you're not in a river. When you're in an ocean, because of the rotation of the Earth, the direction of going from, what we say like high potential to low potential, if we use physics terms, is not necessarily going down the hill, so to speak. But in a river, that is the case. Like when you're in a terrestrial landscape and you have a river, gravity drives water from high to low. And then at times, the water is concentrated enough to scour a channel. So if you don't have a channel, if you just have a big wide spread of water flowing over a surface, that's not a river. That's just sheet wash, okay? So a river requires a channel, and the channel is specifically formed because water is concentrated enough to scour a channel. So you can see with just these 3 bullet points, when we say the word river, we're already implying an awful lot about it. Like we're implying the water, we're implying gravity, we're implying forces strong enough to scour a channel. So that's what is important. And that's why the word river has meaning. I mean, why do we have the word at all? We have it because it helps us communicate with each other and understand the origins and processes that a thing has. Now, Two, just as there are things that they all have in common, there are differences. Here are two photos. We have a bedrock mountain pothole river on the right with those waterfalls and the kayakers, and we have a ditch that somebody carved with, an excavator or something in the bottom right. These are not the same. They are both rivers, but they are not the same type. They are different. They have different origins. They have different processes. They have different ecosystems. Like they are different. And that matters. And that should matter to how we think about our land and manage it. And that leads us to one of Thornbury's principles. So Thornbury was a geomorphologist who wrote a textbook in the 1950s. I was put onto it by Reds Woolman. And there are these sets of principles that are there. And one of them addresses this topic. It says, geomorphic processes leave their distinct imprint upon landforms, and each geomorphic process develops its own characteristic assemblage of landforms. Now, of course, with any principle like this, you can find exceptions, there's challenges, and the other principles tend to bear on it. But let's just take it at face value for now. Geomorphic processes leave their distinct imprint on landforms. I mean, look at the two photos. That's what they show. A step pool with potholing dominant processes versus a vanilla ditch over here, so to speak. Agricultural ditch. They have very different processes, and those processes leave distinct imprint on their landforms. And just again, like, well, what is the name? Like, does it matter if I call something a blotty blotty bloody blue or something, in my textbook, spargles versus knickknacks or whatever. So we have this word riffle. Riffle is a very common term you hear about rivers. Oh, it's a riffle pool river. Riffle, I mean, while I'm sure it has an origin, it really doesn't mean anything inherently. It's just a bunch of vowels and consonants thrown together. But when we say riffle, we have something in our mind. Like a fisherman has something in their mind, a geomorphologist has something in her mind. Like people have something in their mind, and it isn't inherently discernible from a name. If I just say spargle to you, like, does spargle mean something? No. But if I give you 10 hours of lectures about spargles, then they suddenly mean something to you. Okay, so we shouldn't be afraid to create names and descriptions as long as we also then perform studies that help us understand how they work. That's what matters. So the name is just a name, like try not to get too hung up on names. Why do we need a San Francisco Bay Area classification? First of all, so here's some potential criticisms. First of all, well, there's already many classification systems around the world. Why do we need another one? Or well, shouldn't a global system work? Well, I mean, if something works for the whole world, why don't we just apply it in our area? And then, well, why do we need a classification at all? Like, what use is classification? So these are some of the typical criticisms that, that I would hear anyway. Just among those who criticize classification, that's what they might say. Well, first of all, prior to the work I'm going to be presenting you, like what we've done, there does not exist any classification for any region or for the world spanning artificial and natural river types. There are a few artificial river classifications, very, very few. I mean, it might be like, especially in the mining context. I know of an article that talks about different kinds of mining rivers in Australia. A few other examples, agricultural drains of different kinds people have described, but spanning all of the possible artificial types, like even defining what is an artificial river, that really hasn't been done. So having a system that spans artificial and natural is something that is essential for the Bay Area. We don't even know how many artificial sites do we have and what are the different kinds. Like it's essential to get started with figuring that out. And then another thing, if you've been watching my channel and you've been watching the videos, you've seen already, right? The statewide classification, which only has 12 classes, underperforms time and time again compared to each of the regional classifications that we've made. So if I'm on the North Coast, I might find that, the specificity of like a partially confined riffle pool, bed undulating with undulating channel might be unique to that setting that doesn't say exist in the South Coast, which is so dry, right? Or the South Coast might have split channels that we don't have in the Sacramento watershed. So you can have a global classification or a national classification, but they just aren't going to hit the unique aspects of processes and landforms that exist in an area as well as a regional classification. We've just seen that over and over again. And also, why does that happen? Because the geology and ecology that is present in a region they're just across the world is so different. I mean, what's going on in the outback of Australia is not the same as what's going on in the Mojave Desert of California. Like these, it's just not the same thing. And for all the diversity of climate, tectonics, land use, vegetation, soils, like these so-called genetic factors, to come up with a classification that would cover them all would require hundreds of classes, and scientists are afraid of making such big classification systems. Okay, so that is okay. And then I think this is the last point. So what is the use of a classification? Like how do we actually go about using it? Why do we need it? And the main point here is that classifications help set expectations. I mean, first of all, from an educational standpoint, again, going back to Confucius and Davis and Thornbury, when you can put a name to something and you can understand its origins and its processes, then you can better function in that landscape, understanding what it is. Most importantly, though, we're going to say from the outset, a classification shouldn't become dogmatic. Why? Because there's always the peculiar river, and that's a term that comes from a book. It's called The Peculiar River, I think, and it's about a river in Oregon. But I've taken that more generally to imply in any local setting, you can have a peculiar river. It defies what the sort of dogma or wisdom is for that area. Um, it's not defying the laws of physics. I mean, there's no magic to it. It's just that there's a unique set of conditions there that are not represented in the classification. So the classification helps to set expectations, but it must not become dogma. Having said that, there's so many things you can do with the classification because for any particular river type, it's going to have a set of societal uses, natural hazards, human impacts, management strategies, and restoration methods that some or all of those may be unique for that stream type, right? And so knowing that setting just instantly tells you, okay, I need to do A, B, C, not D, E, F, right? So it gets it set up. Do I want to focus on plantings? Well, if I'm in a bedrock river in the mountains with pothole waterfalls, I don't need to do plantings most likely, right? But maybe I'm going to need to do flow re-regulation. So, that's all how we would use it. Okay, so I'm going to stop there. This is a just basic introduction to what is classification, why do we do classification, what are some of the things that people don't like about classification, why do we need a regional classification, and I'm going to stop here and then we'll move right into the classification in the next step.